Hi there, this is Mr. Sand, and I am going to walk through the dreaded Tiger Woods problem. This problem's all about organization and a simple sort of description of angles involved. So, in case you didn't know, this is a compass. North, south, east, and west. And then you've got the in-between directions as well. So those in-between directions are like this and like that. Whoa. That's northeast, southeast, southwest, and northwest. Okay, so this angle from north in relation to east, the difference between those directions is 90 degrees. The difference between northeast and east, this, even though it doesn't look like it, really is 45 degrees. And each one of these little chunks right here, that's 45 degrees, 45 degrees, 45 degrees, 45 degrees. So that gives you a little bit of a, I guess, a baseline on which you can kind of solve this problem, this Tiger Woods problem. So if you look at the problem, it looks like this. It says, during his first golf tournament at age 2, Tiger Woods actually had a 4-putt one of the holes, meaning he had to putt the ball 4 times before it went in. His putts were as follows. And it gives you the listing of all the different putts. So what we're going to do right now is we're going to break down each one of those putts in terms of its X component, Y component, and then we're going to add all those X's together and all the Y's together. And then finally, we're going to use the Pythagorean theorem to figure out the final vector, all of those putts added together, and the angle from where he started from. Okay, so again, we're adding up all the X's and all the Y's and all those different putts to figure out where he started from and then where he ended up with the ball. So here we go. The first putt was 10 meters southwest, so that's P1. P1 was, putt 1 was P1, I'll just write P1, was 10 meters southwest. So if you look at southwest right here, you can see, all right, well, if we want to figure out what the direction is, we got to keep the directions very clear here. So we can say 45 from the south or 45 from the west. It doesn't really matter. Let's just say, since we're comfortable with it, well, I don't know if we're comfortable with it. Let's say that it's this angle right here that we're talking about. And we're going to just use all the X's right now. We'll do the Y's in a second. So I'm going to keep this very, very, very clear here. We're going to use X and we're going to use Y components for both P1. We're going to go through this for every single putt. And it's going to seem boring and like a chore by the end, but believe me, if you can stay organized like this in these problems and keep your thought processes clear, then you will be able to solve any problem that comes to you. So P1's going southwest. It's 10 meters. So if you think about what this might look like, it'll be like this and 10. So 10 meters here. So how do you find the X component of this? The X component is going to be right there. So if this is 45 degrees, this angle right here, and that's 10, well, then the X component of this is going to be 10 meters. I'm skipping a step here because we've done this lots of times before. 10 meters, and it's going to be cosine times cosine of 45. And what does that equal? That equals 7.07. 7.07. But I want to point out that we're going to the left here. And I like to say my left is negative and my right's positive. So since we're going to the left here, I'm going to say, well, in the X direction, this way, that's going to be my negative value. I'm just defining this right now. This can be negative, and that's going to be in the plus direction. The same thing for the north and south. This is going to be plus, and that's going to be minus for my Y's. But for my X's, this is going to be negative. So I'm going to put a negative sign right here, just to keep this very clear. Now we could look at the Y component of this vector, and it's obviously going down, so I'm going to make sure that it's going to be negative, whatever it is. So it's going to be negative something. It's going to be 10 meters, and to find the Y component, you're going this direction down here. So the y component is going to be times the sin of 45. This turns out to be the same thing, of course. 7.07. We can say meters because that's our units that we're in. Now let's do putt number 2. Different color. Using asparagus color, even though it looks like it's yellow. I don't know anybody's asparagus that's yellow. If it's yellow, you should throw it out. P2. P2. Right. P2. P2 is 3 meters north. This makes things really easy because if you go 3 meters north, so 3 meters north, that's what it looks like. There is no x component. So we could say 3 times the cosine of 90, but that just equals 0. So we know that's going to be 0. So I'll just make it short and sweet there in our x direction. P2, it also makes it very, very easy. There's no angle here. It's just perfectly straight up. We could do, if you like, if it makes you sleep better at night, we could say, sure, it's 3 meters times the sine of 90. But the sine of 90 just equals 1. So I'll write that just to make you feel better. But it's really, this just equals 1. So it's really just 3 meters. So this is a positive 3 meters. I'm being very casual with my sig figs here. Because this problem, I think, does not take into advantage. Oh, it doesn't. I should have made this very clear with the sig figs. Did I? No, I didn't. How many sig figs should we use? Let's use 3. We should use 3 because we need to get a little more precise with our answer. A little more accurate, sorry. A little bit more accurate with our answer. Okay, on to P3. I hope I haven't lost you yet. P3. P3 is a putt which is 4 meters southeast. So it's going to be like this, 4 meters southeast. We need an x component to this, which is in this direction, and we need a y component, which would be in this direction. So our x component is going to, since this is 45 degrees right here, we'll say that this is 4 meters times cos 45. If it's 4 meters times cos 45, this is going to be 2.83 meters. And it's positive because we're going to the right, and that's what we saw as positive. If we were going to the left, it would be negative. Now let's look at our y's. For the y direction here, it's going to be 4 meters times the sine of something. So we're going down, and this is a 45-degree angle here, so it's, again, 45. But it's going to be going down, so we have it as a negative. So we're going to place that negative on this number. We want to keep track of our direction here. So this is going to be 2.83 meters. Okay, I hope that makes sense so far. Now I'm going to go on to red. Red is going to be 4. That's our Tiger Woods color for his red polo shirt. Okay, 4. It's 0.5 meters west. Again, this makes things very easy if it's in this western direction. So it's going to definitely be negative, and there is only an x value here because it doesn't go up or down. It just goes west. Okay, so this is going to be 0.5 meters, and we could say, sure, we could say cosine of 0 or cosine of 180. It doesn't really matter. It's going to be 1. So cosine 0, sure. Okay. And this is going to be just a negative. I'm putting the negative on there because I'm going left, remember. There it is. And then for P4, if it makes you sleep better at night, you can say sine of 0, but that will just be 0. So this whole thing will be 0, right? Okay, so those are all our x's and all our y's in all the directions. So I'm going to use a gray color to add up all of these. So if you add up all those values, you're going to end up with, drum roll, 4.74 meters negative, because we're going, overall, it's going to the left. And over here, use a different color. I'll use teal. Teal will be our y. So our final answer here, if you sum up all these values here, it's going to be negative 6 I don't know why I don't do any other sig figs. 6.9 meters. Okay, so this tells you overall in our x direction we're going this way, and overall our y direction we're going this way. So our vectors overall, for all the putts added together, we've got the total y value of negative 6.9 meters. And overall, in our x direction, we're going this way, negative 4.74 meters. Okay, now we can treat these as positives or negatives or whatever. It doesn't really matter for our triangle here. We just want to find out a direction, so from our starting point to our end point. That's where he started, that's where Tiger started, and that's where he ended up. So that's where the hole is that he's putting to. We want to figure out the length of that line, and we want to figure out the angle. And it could be the angle from here, or it could be the angle right here. I'm just going to choose that angle right there. That angle right there. That angle, we can figure this out. How do we figure this out? Trigonometry. Yes. So if you use the inverse tangent, so we'll do that, or arctan, whatever way you like to say it, it's going to be this. We can use negatives, we can use positives, it does not matter. Negative 6.9. Our angle is going to be, what is our angle? 34.48 degrees. 3 sig figs, 34.5 degrees. Been kind of loose with sig figs. The main point with this is keeping the directions straight and the numbers straight and the trig functions straight. Okay, I care very little about your sig figs if you're getting this correct, but keep track of your sig figs. Okay, that's our angle, but I want to figure out what the length is right here. To figure out the length, this is so easy. We can use the Pythagorean theorem because this is a 90 degrees. So let's do it. So it's going to be a squared plus b squared equals c squared. If you do a squared plus b squared, this is a squared, b squared, and c squared, you're going to get this length right here as 8.37 meters. So that's how far he was from the hole to begin with. That's where he started from, and that's where he ended up. All right, I hope that it helped. Remember, keep things organized, and that will set you free. Ciao.